channel Knowledge Offering. Subscribe to our channel and click the bell icon for the latest update. Today we're gonna start discussing about chemistry for class 11, and that is your class 32. Here we had done your 31st class of the session in the last classes. So today we're gonna start with unit 11, that is the P block element, which we have to continue, and we had done even though many more. Where last topic that we discussed, that's your numerical and about your important trends and anomalous behavior of carbon. So let's go for the same. We will be discussing first of all the table, and then after that the allotropes of carbon, that is your diamond, graphite and many more. So before starting with the same, it's a huge request to all the viewers to please go ahead with like, share and subscribe so that many and maximum people can get the information at once, and whether you can also enjoy the video as well. So let's go for the table first, which is being as follows: bond, bond enthalpy per kilojoule mole inverse. This is a carbon bond, silicon bond, germanium bond, and bond. So bond enthalpy, it is your 348, 297, 260 and 240. Due to the transition, due to the property of the catenation and p-pi bond formation, carbon is able to show allotropic form. And now discuss about allotropes of carbon. Allotropes of carbon. So here the carbon exhibits here that the carbon exhibit mainly the allotropes form, both crystalline as well as amorphous. Diamond and graphite are the two well-known of crystalline form of carbon. In 1985, the third form of a carbon known as fullerenes, that was discovered by H.W. Kroto, E. Smalley and R.F. Kern. For this discovery, they were awarded the Nobel Prize in 1996. Now we discuss about the diamond. In terms of diamond, it has a crystalline lattice. In diamond, each carbon atom undergoes sp3 hybridization and linked to 4 other carbon atoms by using a hybridized orbital in tetrahedral fashion. The carbon-carbon bond length is 154 pm, and the structure extends in space and produces a rigid three-dimensional network of carbon atom. In this structure, directional covalent bond are present throughout the lattice. It is very difficult to break extended covalent bonding, and therefore the diamond is the hardest substance on the earth. It is used as an abrasive for sharpening the hard tools, in making dyes, and in the manufacturing of tungsten filament of electric light. Now we discuss one of the questions here, which is diamond is covalent yet it has high melting point. Why? diamond is covalent, yet it has high melting point. Why? So for that we have a solution here. We'll discuss about why diamond is covalent and yet it has high melting point. Because diamond has a three-dimensional network involving strong carbon-carbon bond which are very difficult to break and in turn has high melting point. So we go for it. Diamond has a three-dimensional network involving strong carbon-carbon bond which are very difficult to break and in turn has high melting point. Now we'll discuss about the graphite here. So let's go for it. So for that graphite, we have a structure of diamond as well. We discussed here in the next way where we'll differentiate the diamond structures, graphite, and as well as your fluorine. So that we'll discuss here. So where I will be made one and one. In graphite here, what is graphite? The graphite has a layered structure. Layer are held by van der Waals forces and distance between the two layers is 340 degree, that I will be explaining you when we are going to draw. Each layer is composed of a planar hexagonal rings layer, and that is composed of planar hexagonal ring of carbon atom. Carbon-carbon bond length within the layer is 141.5 pm. Each carbon atom in a hexagonal ring undergoes sp3 hybridization and makes the 3 sigma bond with 3 neighboring carbon atom. Fourth electron form a pi bond. The electrons are delocalized over the whole sheet where electrons are mobile, and therefore the graphite conducts electricity along the sheet. Graphite that cleaves easily between the layers, and therefore it is very soft and slippery. For this reason, graphite is used as a dry lubricant in machine running at a high temperature where oil cannot be used as the lubricant. Now we'll discuss about fluorine. So we have a structure for it. For diamond it is This is 1:54 p.m. This is the structure of diamond. Now we'll discuss about structure of graphite. That we have as follows. So we go for the graphite one as well. In the same way as I told you that each layer is composed of planar hexagonal ring of carbon atom, which is the carbon-carbon bond within the layer, that each carbon atom that makes a 3 sigma bond, as I told you, and where sp2 hybridization and makes 3 sigma bonds where 3 neighboring carbon atom and 14 electrons form that pi bond, and the electrons that are delocalized over the whole sheet. Electrons are mobile and therefore graphite conduct electricity along the sheet. Graphite cleaves easily that between the layers, and therefore it was very soft and slippery, and for this reason the graphite is used as a dry lubricant machine and running at high temperature where oil cannot be used as a lubricant. So for that we have an structure. Here it is. Okay, how it is. Being used. So for that as accordingly. Deform structure, then further it is connected. So this is the whole structure, where this is the length that we have is, I had told you about it, which is 340 pm from 1 to 2, another 340 pm, and the distance between this is 141.5 pm. This is the structure of graphite. Okay, now I talk about fullerene. Fullerene are made by the heating of a graphite in an electric or in the presence of inert gases, that is your such as helium or argon. The sooty material that formed by the concentrations of vaporized CN small molecules that consist of mainly C60 with smaller quantity of C70 and traces of fluorine, consisting of even numbers of carbon atom up to 350 or above. Fluorine are the only pure form of carbon, that because they have smooth structure without having dangling bonds, and fluorine are cage like a molecule. C60, that molecule has a shape like a saucer ball and called your a Bach fluorine. It contained 26 membered rings and 12 5-membered rings, and a 6-membered ring is fused with a 6 or 5-membered ring. But a 5-membered ring can only fuse with a 6-membered ring. All the carbon atoms of equal and they undergo sp2 hybridization. Each carbon atom forms a 3 sigma bond with other 3 carbon atom. The remaining electron at each carbon is delocalized in molecule orbital, which is in turn to give your aromatic character to molecule. And this ball shaped molecule that has a 60 vertices, and each one is occupied by a 1 carbon atom, and it's also contain both single and double bond with carbon carbon distances of 143.5 pm and 138.3 pm respectively. Spherical fluorescents are also called Bucky balls as well. And now for that, it is important to know that the graphite is thermodynamically most stable allotropes of carbon, and therefore delta FH of graphite is taken as 0, and delta FH values that diamond and the fluorine C60 are 1.90 and 38.1 kilojoule mole inverse respectively. The forms of elemental carbon like carbon black, coke and charcoal that are all impure form of graphite or fluorine. Carbon black is obtained by burning hydrocarbons in a limited supply of air. Charcoal and coke are obtaining by heating wood or coal respectively at high temperatures in the absence of air. Now we go for it. We'll discuss the uses of carbon in the next coming class, which is very important. Okay, I will do here itself so that it will be helpful for you. And so let's go for it. Uses of carbon. In terms of uses of carbon here, graphite fiber embedded in plastic material of form high length, lightweight composite, and that the composite are used in the products such as tennis racket, fishing rod, aircraft and canoes. Being a good conductor, graphite is used for the electrode in batteries and industrial electrolysis. Crucibles made from graphite are inert to dilute acid and alkalis. Being highly porous, activated charcoal is used as absorbing poisonous gas, also used in fillers that to remove organic contaminators, and is air conditioning system in control order. That is, the carbon black is used as a black pigment in the black ink and as a filler in an automobile's tires. Coke is used as a fuel as largely reducing agent in metallurgical diamond, and metallurgy diamond is that precious stone and used in a jewelry. It is measured in carats as well. 1 carat equals to 200 mg. 1 carat equals to 200 mg. Okay, this is what it is. Now we'll discuss the rest in the next semi class, where we'll discuss about some important compounds of carbon and silicon. And this is your, as I told you, this is your 11th unit. We had cover up unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9, as well as unit 10. And this is your 11th unit. You can go ahead, you will figure out all the topics that we had done. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.